So here we go. So we're on practice final exam. This is a practice final exam. I'm just going to jump around and do some of the problems. So here's tangent inverse of root 3 over 3.
And no calculator.
Yeah, this is part 1, which is no calculator. Part 1 will be no calculator at all. Part 2 will be use any calculator you want. Graphing calculator, regular calculator, both, whatever. You get a full sheet of notes for the final, right? Like full sheet, put anything you want, both sides of a full sheet. And definitely, most definitely, the most important thing we've had all semester on your notes, the unit circle, right? You can print out, the unit circle is still online. Print it out, shrink it down, or whatever you want, if you want, or just draw it. Whatever, definitely. So, this is go to the unit circle. Do you remember how to do tangent? That's tangent inverse, notice. Not tangent. Tangent inverse. So let me let you try it. Rather than me just whip it out, you'll get more out of it if you try it and learn how much you remember and how much you need to review. So let me give you a second. We're trying to do, I already forgot, what was the question? Tangent inverse of root 3 over 3, right? Yeah. So that's a question from practice exam 1. We had questions like that on exam 1. I'll give you a second, see how much you remember. So look at a unit circle. There's no way to do it without a unit circle. All right. So, how do you do this? The unit circle is a bunch of sines and cosines. How do I do tangent inverse? I'm looking for some angle who comes out that answer, huh? Mm-hmm. It's a reverse kind of question. That's what inverse questions are. So where's that? How do you do that? Anybody got it? Any ideas?
Cosine over sine.
Mm-hmm.
Cosine over sine?
Sine over cosine.
Sine over cosine, right?
Oh, tangent inverse.
That's not cotan. Okay, there's a difference between, don't think tangent inverse is cotan. Tangent, that inverse doesn't mean 1 over, right? Tangent inverse is not the same as 1 over tangent. That's a different animal. Because 1 over tangent, yeah, that's cotan. But tangent inverse means like switching inputs and outputs, right? So tangent inverse of root 3 over 3 means that's the answer, give me the angle. We're trying to find the angle who comes out with an answer. That says answer there. What's that? 30. How do you know? What makes you think, Erica? I'm not even sure off the top of my head. What's driving your thinking? You just tried stuff out? Yeah. It's a good idea just to try stuff out. So it's going to be like 30 or 60. Let's just try 30 like Erica said. If you grab 30, remember it's cosine over sine. Cosine sine, cosine sine, cosine sine. Just go around. So you grab 30. Tangent is sine a half over cosine root 3 over 2. So so we're just trying 30. We're just trying something. Good way to start. Just try something. So you see I just put sine over cosine. I'm going to see if I can simplify that. See, this root 3 over 3 has been very simplified. So the halves cancel, and you get 1 over root 3. Is that the same as this? Yeah. Mm-hmm. Multiply top and bottom by root 3. That's it. It's 30 degrees, isn't it? Hey, by the way, remember where a tangent inverse, remember the limited restrictions on the inverse trig functions? Where's tangent inverse and sine inverse limited to? Remember, everybody uses the first quadrant. And it's these two, remember? Yeah, sine inverse and tangent inverse, it's these two. Cosine inverse, it's these two. Remember, everybody uses the first quadrant for their positive answers and one other quadrant for their negative answers. So we should have known, of course, to look in the first quadrant because this is a positive inverse function. It's positive root 3 over 3. So it had to be first quadrant, didn't it? So we knew, and so really, and it couldn't have been 45 because that's the root 2 values. It doesn't have root, it's got root 3 in it. So it had to be either 30 or 60. Those are the only two that were reasonable to try. So, yeah, 30. 30 degrees is the answer. So we go back with 30 degrees, 30 degrees. Which one is 30 degrees? Pi over 6. Good? Coming back to you? Remember that? That's why we review. All right, I'll move on. Regular normal tangent will be x. Right? Tangent inverse of x equal, I just wrote equal theta because I needed some angle. So that means tangent theta is x. Okay, so how do I put that on the triangle? What do you do for tangent? What's tangent? So good. Yes, exactly. Good job. Good job. X over 1. Make that x over 1, huh? Perfect. Tangent's x over 1. Yeah. So katoa, that's opposite adjacent, right? So this is the opposite side, adjacent side, hypotenuse side. And so that means x over 1 like that. Is that good? Now, can we get the hypotenuse? The Pythag, right? A squared plus b squared is c squared. Which one? And when you do the Pythag, you got to know which one's the c. Which one's the c? Always the hypotenuse. So that's the one I don't know. The other two are a and the b, and it doesn't matter what order, right? A and b, who cares what order? 1 squared plus x squared. So that's 1 plus x squared is c squared rooted. So this side is the root of 1 plus x squared, isn't it? A little scribbly there. Good. And now, are we ready to wrap this problem up? What's their question? They want the sine. What's the sine? Of inverse tangent, by the way, what is inverse tangent? It's theta. See, inverse tangent equals theta. So they want the sine of theta. So the sine of this angle theta. Opposite over the hypotenuse. It's going to be x over the square root of 1 plus x squared, but can't leave a root on the bottom. So we multiply top and bottom by root of 1 plus x squared. Makes a plane 1 plus x squared in the bottom, right? Because two of the same roots. Make a plane. On the top, x root of 1 plus x squared. Where is it? Isn't it D? And they switch the order, but it doesn't matter. Same thing, right? X squared plus 1, 1 plus x squared. What's that? Oh, does it?
Yeah.
Where's it say? Oh, good. Using right triangle. Yeah, that's helpful. See how merciful I am? Yeah, good. That is good. Good point, Samuel. That's a good point. Read the words. Yeah, because I know a lot of times, me too, I just skip right over the words, huh? Yeah, and I know students do that sometimes too. Yeah, those words sometimes really help. Yeah, good point. Thanks for bringing that up. Is that good? Is that coming back to you? Mm-hmm. Yeah. You know, you've noticed in my class there's no skipping the final, right? Because I get that question, like, can't we just skip the final? My daughters think I'm the evilest teacher in the world that I don't let people skip. Like, even if they're getting an A, they can't say it's not. Because almost everybody I know, you know, at least non-math faculty, they always, and a lot of math faculty too. I'm a big believer in finals. My experience was I hated math finals, but they taught me so much. Studying all the material a second time sunk it in deep. That second look, hey, Wendy, that second look made it really like, oh, I get it better now. And so that's what I want for you. That's why I'm requiring the final, even for those getting an A. The final will be part of your grade. But I want to make it positive too. There's hope, right? It'll replace your lowest score. Does everybody remember that? Mm-hmm. So among your 5, it'll replace your lowest score. So it'll count double. So the final will count 100 points on its own for everybody. And if it helps you, meaning if it's not your lowest score, if it's higher than one of your other 5, then it'll count there too. It'll literally replace your other lowest score. And it'll benefit you understanding-wise. Okay. Questions on that one? Number 4? It's all good? Remember all that? It's a pretty tough one. All right, number 5. Is that a good one? Phase shift. So there's a formula. Anybody happen to remember? I'd be very impressed. I'll just write it down. The phase shift formula is actually negative C over B. Negative C over B. And what I mean by CB, I mean this is A, this is B, this is C. The B is actually just the negative 2. It's not the X.
There's a D
Yeah, and if there's like a number out here, like 7 or something, that'd be D. Yeah, that's true. Good memory. Okay, minus, so minus C over B. C is pi over 3. Over B, which is minus 2. Everybody see that? So negative C over B. Now, how do you simplify? Well, two negatives, first off. Two negatives, it's going to be positive, isn't it? Doesn't matter where those negatives are in a fraction. Two negatives is positive. And now, what are we going to do with pi over 3 over 2? How do you simplify pi over 3 over 2? What do you do?
Multiply by.
You could. I like to just put this over 1 and flip it up.
Yeah, that's good.
Like that. Flip it upside down, right? Fraction in the bottom of the fraction. That's really a 2 over 1 fraction down there. Flip it up 1/2. We get pi over 6. Positive pi over 6, meaning pi over 6 to the right. That's the positive part of it, to the right. That's the phase shift. That's the slide on the graph. Good? Questions on that? Let's go to some actual. Okay, so there's the question. All right, so number 6, there we go. Okay, so there's the question. Minus 3 sine 2 pi x plus 2 pi. Not easy. Do you remember graphs? Let me give you a second. So you got to remember, you got to find the period in the phase shift. What's the formula for? We just did phase shift, negative C over B. What's the formula for period? Remember?
B over 2.
Close.
2 over 2 pi over
2 pi over B. 2 pi over B. Yeah, put those on your sheet. You can definitely need those. Yeah, so let me go to a fresh sheet here. 6 y equals, what is it? Negative 3 sine 2 pi x plus 2 pi. Okay, so yeah, so start with the phase shift. Two pi over b. So we'll go, okay. 2 pi over, what's b? This is, again, a. B is the 2 pi, c is the other 2 pi. 2 pi over b, 2 pi over 2 pi, 1. So the phase shift is 1. Not phase shift, I mean the, why did I write phase shift? That was supposed to be period. Yeah. Sorry guys, I'm just losing my brain today. Period. Period is 2 pi over b. So the period is 1. Good. And now the phase shift. Negative c over b, so negative 2 pi over 2 pi, negative 1. So that's kind of weird. Let's go to the graph. How do I graph this thing? Where do you start? Well, yeah, in general, yeah, sine graphs start at their beginning, whatever that may be, usually the origin, up and down. That's one cycle of sine. That's true. Whereas cosine, if we had a cosine graph, that starts high, goes low, comes back high, huh? Right. So remember the general look of sine, one cycle of sine and cosine is like that. We're doing sine, so it's going to generally be this. Yeah. Okay, now, but what do I mean? Do you remember you start at the phase shift? The phase shift is the shift sideways. It's the horizontal shift, isn't it? So you start, that means back here at negative 1 is where he's going to start. Okay, and where does he end? One cycle. Where does he end his first cycle?
At the origin.
At the origin, because it's phase shift plus period. So you really want to remember, let me write those down for you really clearly. You start at the phase shift, and you end at the phase shift because plus the period. Because remember, the period is the width of one cycle. So if you start at negative 1 and the width is 1, then you add 1, you get to 0, don't you? Does that make sense? The width of one cycle, that's what period is. The period is how wide one cycle is. So you start at the phase shift, you add the period, right? That'd be -1 plus 1, 0. You're going to end there at 0 because the width of one cycle is 1. So everybody remember that? You start at the phase shift, you end, it says end at the phase shift plus the period. Hard to remember all that stuff, huh? Okay, now, so between here and here, between the start and the end, one full cycle of sine. What does sine do? It starts in the middle, goes high, goes low, back to the middle, but -3?
Negative, so you go down.
Go down first, then up. Right? Yeah, Rebecca.
So,
Oh yeah, we're going to get to looking at the options, and that's really hard. But everybody good with this before we even look at the options. You got to get this part right, and it's still got a lot of hard work to go because the options are very confusing. But is everybody good to hear? See how this will not come to the casual. And that's what the whole math science world is trying to do. They don't want the casual getting a STEM degree, and the casual will never get a STEM degree. Only the intentional, those that give themselves. Really, honestly, you probably look at me as a math person, and I guess I sort of am. From a young age, I liked math and did computers and all that stuff. But I gave my life to this stuff for like 6 years in college. I mean, it was my life, night and day, working on this stuff. So, starts here, ends here. Now, it seems like, hey, we got it. Let's go find it. Well, the options are really confusing. Look at them. Like, which of those is right? Like, what's all this pi stuff on the, I don't want pi. I want -1 and 0. Yeah, this requires greater understanding. You've got to be able to put that together. First off, you've got to realize can you see this one right here? What's pi? First of all, how about pi? What's pi? 3.14, right? It's about 3. Good, let's just call it 3. Good enough. Right? So remember, pi is not only 180 degrees, pi is also just a plain number. You need to have that coming out of this class. The pi can be seen in both ways, depending on what you're doing at the moment. Pi is 3. So right here, pi over 2, that's half of it. That's about 1.5, isn't it? And this is -1.5 and -3. So let's put those on the graphs here. -1.5, -3, 1.5, 3. -1.5, -3, 1.53. This will help us immensely. -1.5, -3, 1.53. All right, now, what do? We start at -1, do a whole cycle by 0. Now, which one? Let's take them blow by blow. How about this? Does this one look like? It looks like he's starting there and ending there. Oh, no, wait, I'm totally confused. What is he? He's not right. He's crazy. He's supposed to be starting at -1. Where's -1? Well, it's kind of close to -1.5. I'm supposed to go down first anyway. Oh, wait a minute. That might be right. Hold on. It's confusing for me, too. Right there. So there he is. Goes down, goes up, comes back to the origin. Maybe. Let's hold on to that for a minute. We'll see. Okay, let's try the next one. Remember this thing's supposed to go down first, then up, then back to this. So which ones go? This one? No, this one goes down, and then that's not right. See how this one's not right? It's supposed to, one more time. It's supposed to start out here, go down, up, origin. So right, left of the origin is supposed to be down, up, origin. Right? This one does not do that. This one goes. His last cycle goes up, down, origin. No. That's out for sure. We good? How about this one here? His last cycle goes down, up, origin. Yeah, but he's not right either, even though he does that right. Excuse me. Yeah, he's back at -3. He's back at pi. He's only supposed to be back at 1.5 or 1. So he's out. Good? How about this one? What's he doing? He goes, his last thing is up, down. Well, no, I guess not. Look here again. He goes down, up, but then he doesn't hit the origin. He misses the origin. He's out. Hey, good, it is A. I dismissed A early on. I don't know if you heard me say that. I was wrong. It is A. Yeah, and if you look closer, it is A. See this dot? That's before 1.5. So, I mean, it looks like it's at -1, right? Because this is -1.5. So yeah, it's looking right. That wasn't easy, huh? That won't come to the casual. Does that make sense? Everybody good with these steps? So make sure you practice that. And practicing it one more time will sink it and solidify it in your mind. Period's 2 pi over b, phase shift negative c over b. You start at the phase shift. You end at the phase shift plus the period. And then you got to, if they give you weird stuff in the graph, change them into normal numbers. And then just reason it out. All right. You want to try that one? So now they're giving you the picture. They want the equation. That's the work backwards kind. Give you a minute. What are you going to do? What are you going to do? You really need to hone in on one cycle.
Well, it only can be C or D, right? Yeah.
Why is that?
Because the magnitude starts at 3.
Oh, good eye. I didn't even notice that. Yeah, good eye. Yeah, it's going up to 3, down to negative 3, so no way with the 2 thing, no way with the 2 thing. Good job. Good observation. C or D?
No, my chances are 50.
Yeah. Yeah, you can roll the dice. Flip the coin. Yeah, 50-50 at this point. That is a help. All right, so now to narrow it down between the two options, you want to make one cycle, right? There is one cycle for cosine. He's a U-shape, isn't he? That's one period, one cycle for him. So what's his period then?
0 to 4.
4? See, he ends at 4. That's why I did that, so we could identify the period. Do you see that? That's one cycle. So it's confusing because they give you more than one cycle. That's the whole thing we're trying to get really strong at in this class, is the ability to look at these graphs and hone in on one cycle. That's real knowledge of sines and cosines in their graphs. So the period, so it ends here. Right, it goes from 0 to 4. So the period is 4. Period is the width of one cycle, isn't it? And one cycle for cosine is a U-shape. There's a U-shape right there. Yeah, and these are all cosines, so that's a U-shape. So there it is, period 4. What's the period formula? 2 pi over b. Yeah, so the period put in the 4. So 4 is 2 pi over b. Tracking with me? See how we do that? So period's 2 pi over b. The period's 4 by looking at the graph. One U-shape goes from 0 to 4. Put this over 1, diagonal, diagonal. What do we get? 4b is 1 times 2 pi. 4b is 2 pi. How do you solve for b? Divide by 4. b is pi over 2. It's d. Is that what you would have guessed, Samuel? Yeah. All right. There it is. When I say the b, I mean, remember, it's a cosine bx, right? So the b is the pi over 2.
I looked at that. 2 divided by 2 would be 1.
Okay. Good there? Does that make sense? How I did that? So I looked at the graph. One period, well, is 4. Period equals 2 pi over b. Solve for b. It's pi over 2. All right, number 9. 20 minutes left here. Let's get done what we can. Number 9, cosine 285. Hint. It's always hard ones when you got to give a hint, huh? Rewrite this as the cosine of two angles added or subtracted, then solve. I don't know if is this worth our time? Maybe. I'll try that. Number 9. So 285. You want to think of two easy angles, because you'll have your unit circle. It's part 1. No graphing calculator. No calculator, but you'll have your unit circle. So you want to think of two easy angles that they're on your unit circle that you could together make 285. What angles are they? 45 and 240, probably. There's other ones, I'm sure. But I'm thinking right away of 240 and 45. That makes 285, doesn't it? And we know 240 and 45 are both on our unit circle. Very common, normal angles, right, that we use. So do that. So what I'm saying then, let me make this more clear. Okay, so what we're saying is we'll make this cosine of 240 plus 45. That's still 285, isn't it? But now I've broken it into two angles I can deal with without a calculator.
And we just find the cosine of 240 and the cosine.
No, we had a special formula. Yeah, no, you can't. Yeah, good point. So Samuel's question is a really good one. I'm sure many other people have it. Does this just equal? Can you just say, well, just do the cosine of 240 and do the cosine? No, there's no such formula. You can't just distribute. That's an important thing. As you're moving into higher math now, you have to realize just because something's outside of a parenthesis doesn't mean you can just go to those two. That's not always true. That's usually not true. Because this is not multiplication, is it? So you can't just do that. We had a special formula with how you do it. What was it? Cosine of A plus B is cosine, which you'll have on your full sheet of notes, right? Cosine, cosine, sine, sine. And so you put the you go 240, 45, 240, 40. Oh, you just put them in order. 240, 45, 240, 45. Remember that? A, B.
Is it added?
Well, I should. And yeah, cosine is not your friend. That's how my buddy used to say it. That I went to junior college and transferred to Cal Poly with. A, B, A, B. He's not your friend. So if there's plus here, that becomes minus. Cosine always does opposite sign. You'll have that in your full sheet of notes for the final, right? So therefore, this becomes cosine 240 cosine 45 minus sine 240 sine 45. So then you go to the happy unit circle. And you go, okay, 240 right here, cosine sine. There they are. And what's the other one? 45? 45 right here, cosine sine. So there's our values. Let's go back. So the cosine of 240, the cosine of 240 is negative a half. The cosine of 45, root 2 over 2, minus sine of 240, sine 240, negative root 3 over 2, sine of 45, root 2 over 2. See that? Is that good? And now, multiply these together. So these guys multiply, you're going to get what? Negative root 2 over 4 plus, see the two minuses will make plus, root 6 over 4. Uh-oh, the answers don't look like that.
To put them together over the same denominator.
That's not going to help a lot. Still doesn't look right. What are we going to do? I would take those and just multiply them out, see which ones are right. But it's got to be one of the ones over 4. It's just A or C, huh? The only two we're even going to try is A and C. So try A. I'd come up here and try A.
You can pull root 2 out. Yeah.
And if you go boom, boom, you're going to get root 6 minus root 2. But there's a negative here. Do you see that negative?
Yeah.
What is a negative in front? This is where you got to be really clear on these algebra rules. What does a negative in front of an entire fraction do?
All of them.
It goes to the top and hits them all. Or the bottom. It's either way. But wherever it goes, it does them all. So if you take it to the top, take that negative, it'll hit this guy and this guy. Is that right? No. We want negative on the root 2, positive root 6. Is it this one then? Boom, boom. That'd be root 6 minus root 2. Yeah, that's it. Because we have positive on the root 6 and 8. So order doesn't matter. Remember, order doesn't matter. Signs in the front matter. So C is correct. Because what? If you FOIL that out, distribute that out, I mean, you get root 6, which is positive root 6, right? No sign in the front, which means same as positive. And negative on the root 2. Negative on the root 2. That's right. C. Everybody see that? That one's the same? Can you do all that day after tomorrow? Only if you put in hours between now and 2 days from now. Make this your priority. Do your job after Thursday. Do your other things after Thursday. Good? Shall we move on? Questions on that one? So, okay, so cosine 3 pi over 8. It says hint, whenever they come in hint, you got to track. Rewrite the angle by doubling it and then replace it with half. What does that mean? You take the 3 pi over 8. In fact, you know what I do? I would just change this to degrees right away. So let's put in 180. What is this thing? This is 3 times 180 over 8. I don't know what that is. Whatever that is. 3 times 180. Oh, no calculator on this part. No calculator. Just kidding. So 540 over 8. Right? Is that what? 300 and 240, 540. So just multiply that out. 540 over 8 and then long divide. 8 goes into 540. How many times? What it is? Goes in 6 times 8 is 48. 60 is left. 5, 6 times 8, 7 times 8. 7 times 8 is 56. Subtract 4, add a 0, bring it down. 0.5. That's 67.5 degrees. Everybody okay with that? Remember long division from your youthful days? I got 67.5 there. All right. So that's the cosine of 67.5 degrees. Right, long divided. Okay, so what do they want me to do now? They want me to double it. See what they're saying there? They're saying double it. Okay, so if I take 67.5 degrees and I double it, 10, 14, 12, 13. Dead decimal goes back 1, but remember all the decimal movement stuff? So it's 135 degrees. So they want me to double it and replace it with 1/2 the double value. In other words, cosine of 1/2 times 135. Yeah, because 1/2 of 135 is 67.5 is the original question. This is a fancy, weird way to rewrite the original question. Do you see what they're saying? Yeah. They're saying double it and then put a half in front. So it's the same as it originally was. See what I did? I took the original, I doubled it, but put a half in front. Half of the double value is the original, isn't it? Now why? Why am I doing all that? Because 67.5 is not on my unit circle, but 135 is. Yeah. You see that? Question?
The 3 pi over 8, if you're just doubling it, 3 pi over 4, you just find out the unit circle.
Yeah, that might be easier, huh? I probably did way too much work. You're probably right. Well, let me redo that. Never mind. You're right. I'm totally convinced by what you're saying. It would have been easier just to take the 3 pi over 8, double it. 2 over 1, 2 goes into 8 4 times. That'd be 3 pi over 4. So that's the double. That's doubled, right? So then you just say, okay, it's the cosine of 1/2 times 3 pi over 4. You're totally right. It was hard doing all those. I thought going to degrees would be easier. Only with a calculator, huh? Only with a calculator is it better to go to degrees. See, that's 3 pi over 8. That's just a weird way to write 3 pi over 8, isn't it? Right? Now why? Why are we doing that? Because 3 pi over 8 is not on our unit circle, but 3 pi over 4 is. Right? We don't have a calculator in this part. We need our unit circle. You can't find, if you look up cosine 3 pi over 8, it's not in your unit circle. But 3 pi over 4 is. But you have to use the half angle formula. What's the half angle formula? I don't remember. You remember? Half angle formula, cosine, there it is. So cosine, you'll have it on your 3x5 card, or your full sheet of notes. Cosine of theta over 2 is plus or minus the square root of 1 plus the cosine of theta all over 2, right? Yeah, that's it. So you'll have that on your sheet. So therefore, this is equal to plus or minus, and we'll get that in a minute, the square root of 1 plus the cosine. This is the theta right here. 3 pi over 4 all over 2. Everybody see that? Everybody see what I did right there? Am I losing it? So this formula says if you have an angle, but you're taking half of it, the half angle cosine formula says take plus or minus 1 plus the cosine of that angle. So I have an angle, but half of it. So put it in there. Now, that you can go to your unit circle. Cosine 3 pi over 4. Let's go to it. 3 pi over 4 right here. Cosine sine. Cosine's minus root 2 over 2. So then this becomes, this part becomes plus or minus 1 plus, was it positive root 2 over 2? What was it? Or no, negative. Negative. It's important. So 1 just going to become minus root 2 over 2 all over 2, huh? Now what about this plus or minus in the front? What's up with that?
The angle, or the...
That's the original angle.
The original angle.
Position of the original angle. Well said. The original angle is 3 pi over 8. Remember, we actually figured that out. That was 67.5 degrees. That's first quadrant, isn't it? Everything's positive. So get rid of the negative option there. We good to there? Now we got to simplify that. Wendy.
I have another shortcut where if you draw the graph and you have it as the double angle, so like 135, and then you draw another line to split it in half, it'll
Good.
take you to where the quadrant.
Yeah, I like that. I like that. So Wendy's plan is you say, look, if you just say, here's the 135, right, which we're using, the 135, the 3 pi over 4. How about that? Here's the 3 pi over 4, right? And you and that's we're taking half that. This is the half angle. So split that in two. You'd be somewhere about there. You'd be in the first quadrant. She's just pointing out. You can find the quadrant. Try just splitting the angle in half. Where are you at? You're in the first quadrant. You're right around here or so. Good. Good idea. I like that. Good. All right. So now we need to clean this up, don't we? Because we can't have fractions over fractions. So let me get to a fresh screen. I wasn't going to do this whole problem, but it's worth doing. It's a tough one. So we have square root of 1 minus root 2 over 2 over 2. Right? All right. How do we clean that out?
The bottom two of them. So both the one and the other side. Right?
I multiplied it by 2.
There's all kinds of ways. I think the easiest way is just to multiply everything by 2. Because it'll cancel that guy out. I'm doing top and bottom of the fraction. So it's okay to do. I'm not changing anything as long as you do the same thing top and bottom. So what do I get? Root of 2 minus root 2 over 4. Yeah, that's nice. You see what I did there? Multiplied by. So whenever you have fractions over fractions like that, I'll separate it with pluses and minuses, everything. I multiplied everybody by 2. These guys canceled. And this 2 times 1 and 2 times 2 multiplied. Now, that's not it. Why not? Well, root over a whole fraction goes on the top and on the bottom. And what is the bottom? What's the root of 4? That's just 2. The top can't do any more, so there it is. It's the same thing as a half in the front. It's D, isn't it? Yeah. The 2 in the bottom, same thing as a half in the front. Whew. That takes practice. That takes hours of your life. Took hours of my life. All right, the hours are going by quick. Let me just do one of these solve them ones, because these were chapter 3. That was all chapters 1 and 2 stuff, I think.
How to add, angles.
Right. Some crazy thing happens, yeah. Good. We just got 2 minutes. Let's just do this. Remember these solving ones? I wish I had more time. Because they're all on YouTube, so you can go back and, I'm referring you to where to look, and they're out there. This is like solving. Remember what we had to do? You have to find, where is cosine root 3 over 2, first off? Go to the unit circle. Where is it? Unit circle. Where is cosine? Let me kind of erase some of these. Where is cosine root 3 over 2?
Positive.
Cosine sine right there. And cosine sine right there. See how cosine in both those places is positive root 3 over 2? Pi over 6 and 11 pi over 6. So you go back here and go, okay, so the angle 2x is pi over 6, or the angle is 11 pi over 6. Right? Because the angle, the cosine of what angle is root 3 over 2? The angle, the 2x. The 2x is the angle, isn't it? Must be pi over 6 or 11 pi over 6. But remember when you have a 2x, what you have to do?
What?
You have to add plus 2n pi.
Oh, yeah.
Plus 2n pi, or 2 pi n, or however you want. 2 pi n is whatever, same thing. 2 pi n. Remember that painful process? 2 pi n. And then you divide through by 2. Divide by 2. Multiply the denominator by 2 and divide by 2. Remember, when you divide through by 2 to get plain x, you have to multiply the denominator. So you get pi over 12 plus, and these 2's cancel. Pi n. Same thing over here. Divide through by 2. Multiply the denominator by 2. So x equals 11 pi over 12 plus pi n. Remember that? See what I just divided through by 2 to get x alone? And then you got to plug in the various cases for n. Remember in all this? We did some hard stuff. So that was, then you got to go, okay, n equals 0, n equals 1. Right? We need 2 answers for each of these. So you get pi over 12 plus 0. Pi over 12 plus pi times 1. So you're going to have to get common denominator there, right? Put this over 1. Top and bottom by 12. This will be 13 pi over 12. 13 pi over 12 and pi over 12. The other side, let n be 0. N be 0, you get 11 pi over 12. And let n be 1. You get 11 pi over 12 plus pi. Got to make that 12 pi over 12 pi. That's 23 pi over 12. There's my 4 answers. Pi over 12, 11 pi, it's D. It's always D. Pi over 12, 11 pi over 12, 13 pi over 12, and 23 pi over 12.
You have a child that has a name of Daniel or something?
I do.
You do?
Why do you? Oh, you think that's why I'm picking D? I got an A for Abby. I got an E for Emma. I don't know.
Okay.
So it's your favorite?
Daniel's mine.
That's my favorite thing.
All right. So, all right. Well, we are out of time.